to go.
Hello, welcome to Chemistry in Action. I'm Miss Michaela LeClaire. I am a chemistry teacher here at Blankety Blank High School. Today, we will be looking at why chemistry is an engaging and exciting subject worth deeper exploration. Few little things: if anyone does have to use the bathroom, please use it now, because once the presentation does begin, you will not be able to get up due to the nature of the chemicals. With that also in mind, food, water, keep it to just water. Your LaCroix is fine. Take a good sip right now. That being said, I'm wearing proper PEE. I have my lab coat on. I'm going to put my goggles on later in the presentation when I'm going to be working with a little bit more potentially hazardous materials. If something does go wrong, remain calm and move in an orderly fashion out of the room, avoiding this area. Okay, let's get started. When you think of chemistry, what do you think about in one word?
Reactions.
Reactions. Hard.
Boom.
Boom. I heard that one a couple times. Anything else?
Explode.
Explosion. Who here likes chemistry? One person. 2 people? 3 people? Okay. Okay. Hoping to change your mind. So, for the next 10 minutes, we will be talking about why chemistry is exciting and engaging and why it is worth deeper exploration. So, the first thing we're going to talk about is environmental chemistry. Who here knows what an acid is? Just a raise of hands. Okay. So, an acid is a chemical compound with a high concentration of what element? Who can tell me what element?
Hydrogen.
Hydrogen! Yes! So, when we think about acids, they can be good. I mean, we digest our food with acids. Yeah? Yeah?
Yeah.
Okay. But they can also be really bad for the environment. One way acids can be really bad is something called ocean acidification. Who here has heard of ocean acidification before? You're in a biology class, so could have heard of it, could have not heard of it. So ocean acidification is when CO2 released into the atmosphere due to our actions, breathing, one of them, not the biggest one, mostly fossil fuels. Driving our car, got a lot of carbon going out in there. It will go into the atmosphere and then the ocean will absorb it. This causes a chemical reaction known as ocean acidification. This is when CO2 mixes with water and it becomes carbonic acid. Carbonic acid is a weak acid, meaning it will break down really quickly into bicarbonate acid and H+ ions, which causes the acidity of the ocean to increase. Now we have these 3 animals. What do these 3 animals have in common? We've got coral, a crab, and a clam, or an oyster. They live in the ocean, that's one of them.
Animals.
They're animals. What do we notice
Exposed to the air.
about what's on their body? Shells. They've all got shells or skeletons made out of calcium carbonate. Calcium carbonate is vital to the protection of them. Without it, they are just mushy and they're not going to survive very well. However, we've already mentioned that we have all these H ions. Carbonate loves to combine with these H ions, meaning that when these animals go to try to make their calcium carbonate shells, they can't. There's no carbonate. It's with the H. So, this is what happens to their shells. This is an eggshell placed into acetic acid. This is it right 5 minutes after being placed into a thing of acetic acid. 12 hours, what do we notice after 12 hours? It's kind of gone, it's kind of foamy. 24 hours, even more gone, even more foamy. This is it now. So I'm going to pass this around. Feel free to look at it.
Should we shake it up?
Don't shake it up.
How many hours is this?
This is about, I'm gonna say probably about 40 hours now. So as that gets passed around, I'm gonna explain that a little bit deeper. Essentially, that calcium carbonate shell, that is what an egg is made out of, is disintegrating and it's becoming very flimsy. Now, if I was to open that up and touch it, it'd feel like a wet piece of paper, is what it would feel like. It's not great. So, how does that affect us? So, the acidic ocean causes things like this, which goes into our food web. Who here eats crab? Who here likes a good crab? Who here likes fish? Yeah. Well, that's gonna mess up the entire food chain if all your fish and all your fish can't eat and your crabs look like flimsy pieces of paper. That's also gonna affect the oxygen production. Think about the amount of plants in the ocean. They can't handle that acidic water. They're not gonna be able to produce oxygen. Do you know that the ocean actually contributes to half of the world's oxygen? That would be unfortunate. But now let's go into something a little bit more fun. Who here likes really cool, fast reactions? Yeah. Okay, so we're gonna start with that before I get any further. I have here hydrogen peroxide, something used to clean your boo-boos. Who's got a cut here? Who's ever gotten a cut? Yeah, clean it with a little hydrogen peroxide. So I'm gonna put half a cup of hydrogen peroxide into this container. Ooh, spilled it a little, that's okay. Now we're gonna add some dish soap. I promise this is dish soap, doesn't look like it, but it is dish soap. Next, someone shout out a color: red, white, or red, blue, green, or yellow.
Blue.
Blue? I heard blue. Sorry, going blue. I heard pink, I don't have pink.
It's a green.
Oh. I'm gonna give that a little shake. Next, I am going to grab some yeast. Same sort of yeast you make bread with. And I'm gonna put this into my container. And can I have a volunteer? Anyone want to volunteer? Come on up. I'm gonna have you put 3 tablespoons of this water into there and then mix. Put a little bit more water in there. That's good.
Ooh, I can smell it.
It's just yeast and water, so.
Smells very bready over here.
Okay, very good. You can go sit down for me. I'm gonna move this stuff out of the way so everyone can see. Can you guys see over here? Can you guys see over there? Yeah? Okay. I'm gonna put my goggles on. So just a fun little chemical reaction right there. This chemical reaction is known as elephant toothpaste because it kind of looks like toothpaste. Not edible toothpaste though. Can't use it for your teeth. This is a reaction that you just saw. H2O2, hydrogen peroxide, with the catalyst yeast. Catalyst meaning it speeds up the reaction. So H2O2, normally an oxidizer. Over time it breaks down and becomes O2 and H2O. But when you add a catalyst, it speeds up the reaction. And this is what you get, elephant toothpaste.
Cool.
So, that is my presentation. Thank you. Does anyone have any questions? If you don't have any questions currently, I will be around. But wasn't that exciting, folks? Yeah.
Yes.
Who thinks that chemistry is super fun and super engaging now? Yeah, awesome. Before you go, I have a little takeaway. You guys can do some chemistry at home. You can make some slime at home. Who likes slime? And on the back, it's going to have the chemistry behind slime. Sorry, Mariah. Thank you.
I can share mine with somebody if I need to.